Hello guys, welcome back to the class. And in our previous lesson, as we have already discussed the first method of solving the quadratic equation, which was factorization method. Now moving to the second method, that is completing the square method. And to explain this method, I have taken a question from your NCERT exercise 4.3, question number 1, second part. And our equation is 2x square plus x minus 4 is equals to 0. So once again you have to find the roots of this given quadratic equation by using completing the square method. So this method is a little tricky, but I feel that you can understand it in the best manner. So for starting up the solution here and to find the solution, how to do the method step by steps, let us see. So very first our equation is 2x square plus x minus 4 equals to 0, and as the method is completing the square, that means we need to complete the square on both the sides, that means left side and right side. So very first what I'll write, I can write the equation in the form 2x square plus x, and I'll shift this minus 4 to the right hand side, so that will become plus 4. So I have simply changed a little bit pattern of writing the equation, and equation becomes 2x square plus x equals to 4. Now we have to complete the square on these two sides. That is what is called completing the square method, on left side and right side. So let's see how to do that. So very first here we have 2x square. So if I divide this complete equation, divide the equation by 2. So if I divide this complete equation by 2, my equation will become x square plus 1 upon 2x equals to 4 upon 2. So basically here it was 2 upon 2, so that 2 and 2 cancelled out, 2 2s are 4. So our new equation is x square plus 1 upon 2x equals to 2. Correct? So we have made this because we want our first term in the single format, means with coefficient 1. So I made this coefficient as 1. Now let us complete the squaring on the left side. Automatically the changes will be made on the right hand side. So if we need to make this square, that means it will become a square plus 2ab plus b square. You can just see we have to make it in this format, a square plus 2ab plus b square, so that we can make it equals to a plus b whole square. So we are going to apply this format here. So very first a square, that means x square. So may I write it as x whole square. After that I have to make 2ab. So what will be 2ab? We need 1 upon 2 in the denominator. So what we will do, 2 multiplied by 1 upon 4. Why? Because when it will be get simplified, 2 2s are 4, so you will get 1 upon 2 and multiplied by x. So I have written 1 upon 2x as 2 multiplied by 1 upon 4 multiplied by x, and this is our 2ab, or you can say 2, this will be our b term and this is a term because x is already here. Now since the next term should be b square, so that means what is our b? Our b is 1 upon 4. So that will be 1 upon 4 square. Now to make this 1 upon 4 square, we do not have any term here. So what we have done? We have basically added this 1 upon 4 square both on the left side and also on the right hand side. Because if we add same term to both the sides, it will not make any difference to the solution. Whether you add or subtract any term from left hand side and right hand side both, that means both the sides of equation, it will make the equation same. Done. Now moving forward, and here we have made our equation in the form of a square plus 2ab plus b square and equals to some term on the right hand side. So basically our left term becomes a square plus 2ab plus b square, and what we can write this equation as, we can write it as a plus b whole square, because this is a formula, this is an identity, algebraic identity, that a square plus 2ab plus b square is equals to a plus b whole square. So we have written in the same format. A is our x, that means 1x, and b is 1 upon 4 equals to. Now let us solve the term which is present on the right hand side. So how we are going to solve? 2 plus square up, getting the square of 1 upon 4. 1 square is 1 only, 4 square is 16. In the next step, x plus 1 upon 4 whole square equals to. Taking the LCM here, you'll get LCM as 16, and what you will get here is 32 plus 1. Clear, students? Now moving forward, and now we can write the same equation as x plus 1 upon 4 whole square equals to, what is 32 plus 1? So 32 plus 1 give us 33 upon 16. Done? Next is we will shift the square symbol to the left hand side, right hand side. That means it will become square root. So in the next step, we will write the same equation as x plus 1 upon 4 is equals to square root of 33 upon 16. Correct? We can write it. The square, when shifted to the another side, it becomes square root. Now the next step will be x plus 1 upon 4 equals to this square root. So the square root, we can write it in this format. Square root of 33, because we do not have, because 33 is not a perfect square. So we will write this 33 in the root format. And for this 16, can we write it as plus minus 4? Because yes, 16 is a perfect square. So what is the square root of 16? It is 4. But we can write it as plus minus, because plus 4 into plus 4 is again 16. Minus 4 into minus 4 is again 16. So our equation become x plus 1 upon 4 equals to plus minus square root 33 upon 4. At this last step, we will shift our 1 upon 4 term to the right hand side. So x is equals to plus minus root 33 upon 4 minus 1 upon 4. Done? Now since we need two roots for this quadratic equation, because it is quadratic and we need to find the two roots, so we will separate the two roots by this plus and minus sign. So basically our two roots for this given quadratic equation is plus root 33 minus 1 upon 4. 4 is common because it is in the LCM denominator term. And the second root will be x is equals to minus root 33 minus 1 upon 4. So these are the two roots of the given equation. X equals to root 33 minus 1 upon 4 and x is equals to minus root 33 minus 1 upon 4. So this is, students, how you can solve any quadratic equation to find its root by completing the square method. I hope this method was clear to all of you. Thank you for the lesson, students.